So welcome to this session on sampling and data, where I will be rambling a lot on the theories of sampling. Yeah. Okay, so some of the general basic things that you should know about. Hold up, my tablet is not working for some reason. Oh wait, it's working now. It's weird. Okay. So some of the general terms that you should be knowing about sampling and data is some of the most basic terms like data. So data is an information on the variables. If you have a particular like category or variable, let's just say the category of cars, then if you have like the types of cars, maybe we have Toyota, Hyundai, and etc. etc. And then we have like the number of cars, like we have 1,000 cars for Toyota, and then we have 750 for Hyundai. All of these are what you call as data. So it's basically like any information regarding the variable or the category that you have. And well, there's this specific thing in terms of variables called categorical variables. So categorical variables is a particular thing that can be divided into categories because of its characteristic. The example of this would be something like maybe furniture. So there's a lot of things, furniture. There's a lot of things that can go into the furniture category, like sofas, desks, and then chairs, and many more. And there's also quantitative variable. So quantitative variable are characteristics in its numerical value. For example, desk, the common desk have 4 legs. A common chair might have 4 or 3 legs. While sofas has no legs, aka 0 legs. So these data that are represented in numbers are what you call as quantitative variable. And then another term that you should know would be population. So population is what you call when you're trying to refer to an entire society or entire community as an individual. So for example, we have usually we have population in terms of a country. We also have population in terms of states or cities. And those populations are trying to include everyone who is in that particular area. Or if there's also populations in terms of race, they usually try to include everyone that is a part of that particular variable or category. And then there's census. Census is what happens when you try to record every single one of your population and collect information on them, whether if it's numerical data or whether it's quantitative data, qualitative data. Usually census is done by countries that will try to track every single one of their population. And since you can imagine how tedious it is to do something like that, it's for countries, it's usually done around every 5 years or so. And then there's also parameter. Parameter is the numerical quantity in measuring some population aspect. Um, so not, I mean, I'm not that very familiar with the term parameter. So yeah. And then we have sample. Sample is a group of individuals from population. So since realistically, it would be really tedious if you want to try to collect data from every single one of the population. That's where sampling comes in. You try to take a smaller proportion of the population. And then there's also the term survey. Survey is a form of collecting information from the small population. And usually we would try to want to make sure that the sample is representative of the population. And then next up, we have statistics. So statistics is the quantity from the data gathered from the sample. Most of the time, well, not most of the time, every time you have a statistic, it's usually derived from quantitative variables. And this can be used to help establish parameters about the sample itself. Okay, so in this chapter, we also learned about how to use statistics when you're trying to do an experiment. And that's what you call as statistical investigation. So there are some steps that you need to follow in order to do a statistical investigation. The first one would be to state the problem or the thing that you want to investigate. And then after stating the problem or the thing you want to investigate, you need to choose a sample that helps reflects the population you want to investigate. And then after choosing samples, you collect the data that you want and organize it in a way where you can display it. So after organizing it and displaying it, you try to calculate data to describe the data that is on hand. And after describing it, you try to interpret the data in relation to the data that you have specifically. And in other than interpreting the statistics to the data, you can also interpret the statistics into the theory, but that is a bit tricky. And I think like in maths, we're gonna just go more in depth into interpreting the data itself. Okay, so the thing with sampling is that because we're humans and we're not perfect, and taking samples doesn't necessarily mean it represents the populations. Sometimes there are times when you try to take a sample which does not represent the population. And so there are errorings that comes to samples which we should try to avoid, which we will try to avoid doing when we're trying to take a smaller amount of people to try to represent the data to the general population. So the first error that you have would be the sampling error or random error. Um, these errors are usually unprecedented, and typically it doesn't statistically it doesn't normally happen on average. Um, and a way to avoid sampling errors from happening generally is to increase your sampling coverage, um, or just increase the amount of sampling that you're doing, because sampling error is more of a random chance error kind of thing. So to decrease that random chance of error by increasing the samples that you have, like for example, at first when you start doing your experiment, you only have 20 samples. 20 samples means that there might be a high chance that the characteristics of certain people, since it's very random, might affect the final result of it, just because there happens to be too much people with that particular certain characteristics. And so by increasing the sample amount, we can reduce this particular sampling error. And then there's also coverage error. So coverage error is what happens when you have when you just have issues with trying to target the population itself. For example, you want to look for samples that can represent the general population. But in your experiment, um, you only you didn't consider the um, the sample's race. For example, especially in psychology experiments, there's this phenomenon where most experiments are done by white people. So it doesn't. They always tend to say that the result of the experiment represent the whole wide world, but in reality, it only represents the majority of the experiments represents white people who are um, well in the middle class. So this is what you call as coverage error. Um, and there are several ways to counter this. So some of the ways you can counter it is to either um, specify or narrow down your target population. Or if you don't want to narrow down your target population, another way that you can deal with it is to increase the population sample. By increasing the population sample, um, it can help deal with this particular randomness and decrease the coverage error overall. And then next up, we have non-response error. So non-response error is when some samples are unresponsive because of certain conditions. Um, this can be represented by the example of when you're doing surveys online. So the thing with doing surveys online is that it's only most accessible for people who are well versed with technology. For example, millennials and the generation Zs. So since the people who are outside these generations, like the elderlies, this isn't used to using technology, they are most likely not going to be responding to the survey because of um, the unfamiliarity with digital, with technology in general. And then the last but not least, we have measurement error. This is specifically more into the errors that comes within data collection. So examples of these measurement errors would include something like when you're trying to measure something to the nearest centimeters instead of using decimals. So depending on your experiment, using nearest centimeters compared to decimals can be a very big thing. Because if you're trying to measure something that has like very small change, like the growth of a plant, then measuring the nearest centimeter can most likely result in inaccuracy compared to measuring it per decimal. Or perhaps if you're trying to measure a plant and um, you didn't use the correct tool to measure it, it can also cause inaccuracy, especially because plants are not straight like a ruler. So if you try to measure the height of a plant with a ruler, then it might be more inaccurate compared to measuring the height of a plant using those measuring tapes. And then after that, we have some sampling methods that we can use in general experiments. So we have random sampling, systematic sampling, convenience sampling, stratified sampling, and quota sampling. Random sampling is what you do when you get a population to have the same chance of becoming a sample. So this is usually like something that would happen if we were to have an ideal experimental setup, or if we're experimenting on humans, this would be an ideal experimental setup. We can also use random sampling for example, in terms of perhaps plants or animals. Or maybe if you're trying to experiment on sampling products, then you can use random sampling. And then there's also systematic sampling. So systematic sampling is selecting samples in intervals. Usually these kind of samplings are implemented when you have something like security checks in the airport, or when they have immigration checks for cars. So they can sample in like every 5 cars that passes through, or every 10 passenger that passes through the immigration. That's how you do systematic sampling. And then we also have convenience sampling. So convenience sampling is what you do when you're trying to select samples that are easy to find. For example, if you try to find a sample by going down the street and asking random people on the street to become your sample, that would be what you call as convenience sampling, because the samples won't be random. It would be depending on who's nearest to you, who's most convenient to take. Or for example, if you want to do convenience sampling, sometimes what people do when they sample on people in psychology experiments would be to take a psychology class and tell them to get all of them in a class to do an experiment. And then we also have stratified sampling. So stratified sampling is what you can use, or what you can do when you want to do when you want to do sampling, but you want to make sure that it's proportional. instead of not representative of the population. So let's just say that in this particular community, um, there are way more males than females. And since you know that their opinion would more likely differ, and you want to make sure that like the result of it is proportional to the population in that particular community, then you take a proportion of their sample to ensure that the results is reflective of that particular community. Basically, stratified sampling is similar to quota sampling, but the only difference between them is that stratified sampling is a proportional random sampling. So for quota sampling, in this case, for example, if we have these males and females division, the males will be taken in like a certain group, like in a certain quota. So the people who are doing the research can pick who wants to become their sample. But for stratified sampling, they wouldn't have the researchers pick who's going to be their sample, but it's going to be random, but still proportional. Okay, so next up we have writing surveys. So there are certain guidelines when it comes to writing surveys. And I think this is more specific to AI in reasoning with the interpretation of how to write surveys. So some of the guidelines for writing surveys are as follows. The first would be to keep the questions simple and clear. And then the next would be to ask specific questions. So if you're doing a survey and you're trying to ask someone something, you have to make sure that the question can be interpreted as what you intend to actually ask or what you actually intend to get from them. Because if your questions are very vague and unclear, it might there might be misinterpretations when it comes to other people reading the question, because everyone's perspectives to some degree can be different. And then after that, you also should consider how your questions are structured. So there's the difference between structured and unstructured questions. Structured questions are the kind of questions which have options to choose from. Usually this is something like the true or false question, multiple choice questions, and the scaling questions that you have, like rating scale questions. Meanwhile, we also have unstructured questions, which are questions which is usually more open to long responses or short responses or drawings, because there are questions that ask you to draw things. And then next, we also have something to consider, which is to make sure to keep the questions neutral. This is actually especially important in psychology, because if you don't keep the questions neutral, if you keep it so that the question seems to be leading you onto something, then there's a chance that the person might answer it because of demand characteristics. So there's also the last thing about being wary about personal questions, because personal questions, even if the survey is anonymous or not, sometimes some personal questions can be a bit uncomfortable for some people, especially if it touches a sensitive topic. Okay, so after covering that part, we can now finally go into more of the math-specific parts of data. So there are several types of data. There's the categorical variables, and there's also the quantitative variables. So like I explained before, categorical variables are the variables with oh wait, sorry, that was different from this one. For this one, categorical variables are variables that are based on quality or characteristics or traits. For example, if you have long hair, then you have curly hair, you have wavy hair. That's what you call as categorical variables. They can be categorized as hair. And then there's also quantitative variables. So quantitative variables are the variables which has numerical value. For example, if we have something like your height, this has a numerical value. And so quantitative variables can be divided into two kind of things. We can divide it into discrete variable, and we can also divide it into continuous variable. So the examples of discrete variable would be something like the number of phones someone had during their lifetime. So discrete variables are typically results of counting on something like this, while continuous is more of something that can take any range of values because it's mostly a result of measure, like your height, or maybe like the length of your plant. So since we covered this, let's go more deeper into discrete variables. There are several ways to organize these discrete variables since it's a countable thing. You can organize them into tallies. Maybe, for example, this is the win tally for chess. And then we have 3 people's win tally. Let's just call this person Anna. Then this is Ben, and this is David. This is win tallies are something like this. And then there's also, we can also put this in forms of frequency tables. So an example of a frequency table would be something like this. Or you can also combine both of these into both a frequency table and a tally table. So To display these data, we can also display in form of discrete, in form of a column graph. And um, to describe these column graphs, there are 3 ways to do it. There's the symmetric kind, which is something like this. This is the symmetric form. Symmetric data. And then we also have the negatively skewed data. Something like this. So the data is negatively skewed in the negative, it's negatively stretched. Well, we also have the positively skewed, which takes form and shape, something like this. And then another thing that you should know is that in these data, there's also something called as outliers. So outliers are data that usually are very offset or doesn't fit in the graph. And I think we're going to cover this up later in the next chapter, more in depth into like how to identify these outliers and how to like portray them in also in other forms of discrete data display. So after discrete data, we also have this thing called group discrete data. Group discrete data is usually what happens if you have like big data, big data as of a lot of data, and instead of showing the numbers one by one, we group it so that it's maybe in form of fives or in forms of um, constant intervals. So, for example, we have the data of plates. Maybe in some restaurants we have the data of one to 10 plates. And then in other restaurants, we have the data of 10 to 20 plates. And in bigger restaurants, we might have 20 to 30 plates and etc., etc. So as you can see, these data are countable, but since they're too big, we group it into intervals. So this is maybe restaurants, and then maybe there are 5 in the neighborhood, there's 13, there's 12, there's 16, there's tree. So these data are grouped into what we call as class intervals. And for their column graphs are similar to the ones before, except for this time. So the thing with discrete data is that if you have, like, for example, this data, this would be written in a way that it's 1, 2, 3. But then for the group discrete data, if you have something like above, let's draw an estimation of the graph. Yeah, let's just think of this as the estimate of that graph. I know it's poorly drawn, but I want to do it quickly. You write the data this way. So there's a difference on the lower part of it. And then next, we finally have continuous data. Continuous data, since they don't have an exact value and usually is something that you measure, how you deal with continuous data is that you try to group it like the discrete data into class intervals. But you have to make sure that class intervals have equal width. So let's say that we have the data of a class. And the data of height in a class. Then we can group this into 150 until 160, and then this can be 160 to 170, 170 to 180, and the list goes on. And then let's just say this is 3 people, this is 10 people, this is 16. If we want to graph this, then it's usually in forms of a frequency histogram or histogram. So they would be graphed like something like this. 3, and then 10, 16, and you know, the list goes on depending on the graph. And the shapes has to be in the same interval. And how you label this would be this is 150. Actually, the more appropriate way of drawing this is not like this. Let me just redraw this for a sec. Okay, so the more appropriate way of drawing this would be to stretch it a little and then have a bit of a lightning sign. This usually shows that the data cut off from somewhere. So you don't have to bother to draw like a very long line to make sure that your data is consistent. Yeah, 50, 60, 70, 80, 90, 200, and etc., etc. And then here's the numbers. Okay, so that's it for today's theory.